Yeah, so hi everyone, and welcome to the third day of performance testing with JMeter series, organized by the CQC, which is a bunch of enthusiasts working towards to improve the quality of the software products and processes while filling the gap between software testers and developers. So in last 2 days, our speakers covered what is JMeter, JMeter features, how to set up, record and playback, and parameterization and correlation. And today, in the first half of the session, I'll be covering the script execution order, test execution in local machine, remote execution. And in the second half, Jude will be covering collecting results and identifying matrices. So let's start with the script execution order. Yeah, so when it comes to JMeter test execution, the execution order is really important because it helps you to understand the timeline of the event and how your test behaves. So in JMeter, there are two different kinds of elements which are ordered and hierarchical. Normally, controllers and samplers are considered as ordered elements, and those elements get executed according to the order they appear in the test. And all the other elements are considered as hierarchical, which are config elements, assertions, timers, processors, and listeners. So when both of these ordered and hierarchical elements are present in a test plan, it follows an execution order. So this is how the execution order is arranged. First, configuration elements will be executed, then preprocessors, then the timers, then comes the ordered elements, which are logic controllers and samplers. Then post processors will be executed, then the assertions, and finally listeners. Let's say there are more than one element of the same kind in a test plan, then again, they will follow the order they appear. But remember, always center line of the execution is based on sampler. So if a sampler is not executed, none of its associated supporting elements will not be executed. Right, then let's quickly look at on a simple example that I have prepared. So here I have a test plan with a thread group, and there are few different JMeter elements. So once this test plan is executed, the elements related to sampler 1 will be executed first. So once it is executed, out of other elements applied to sampler 1, timer 1 has the highest precedency. So timer 1 will be executed first. Then out of other elements, sampler 1 has the highest precedence, so it will be executed. Then you can see we have two post processors. One is we have placed one outside the branch and one inside, but both are post processors. So post processor 1 will be executed then. Next, post processor 2 will be executed. Right, then the execution will start for sampler 2. So out of elements applied to sampler 2, preprocessor 1 has the highest precedency. So preprocessor 1 will be executed. Then we have timer 2. Timer 2 will be executed. And then we have a post process. No, then sampler 2 will be executed. Then we have a post processor 2, which is we have placed that out of the branch, but it is applied to sampler 2 as well. So post processor 1 will be executed next. And then assertion 1 will be executed. Finally, listener will be executed. Right, then let's see how we can execute a JMeter script in your local machine. So since our speakers explained these steps in detail in last 2 days, I will just highlight the main points. So before running a JMeter script in your local machine, you have to install latest JDK/OJRE because Apache JMeter is a pure Java application. And of course, you have to download Apache JMeter. And if your test script is reading data from a CSV, you have to keep those files prepared as well. Right, then let's move to the demo. Yeah, so here I have prepared a simple JMeter script which executes a post call for a login functionality for 5 different users. And I have added a listener as well. And if you look closely, here you can see I am saving the response data to a folder called appended results. And here I'm not using bin directory to save my data to avoid the crashing issues in bin directory. Right. So let me execute the script. You can execute the script by just clicking on this start button, or else you can click on this run tab and select start. Yeah, so I have 5 different users, so the execution stops now. And what I'm going to do is I'm going to go to this appended results folder and see how the script has generated the result. So I'm going to open the appended results folder. Here I have a CSV and I'm going to open it. Yeah, so I have data up to line 50 and I'm going to close this. And what I'm going to do is I'm going to run this test again. I think I'm audible.
Yes, Tilani.
Yeah,
Yes,
right.
go ahead.
Yeah, I got a notification that I was muted. That's why I just asked. Right. So now I'm going to execute my script again. And I'm going to go to this appended results folder again. You can see earlier the file size was 5 KB. Now the file size is 9 KB. And if I go to the CSV, now I have data up to line 66. It was 58. Now it is 66. This means my response there, I mean, my CSV keeps all the data. It is appending the results. This is good. Let's say you are doing some small optimizations to your script and you want to see how your responses behave according to the optimization that you did. So this is good in such cases. But let's say that you need to override the data, then you have to simply set a property in the JMeter property file. So let me go back to the slides. Yeah. So this is the property that I mentioned above. So at the current property file, I have kept this result collector dot action underscore if underscore file underscore exit property to append. That is why it is appending all the responses to the same file. And now I'm going to set the same property to delete. In order to do that, you have to go to the bin directory. And there you have to find the JMeter property file. So this is it. And I'm going to open it. And there I'm going to find the property. So this is the property. You can see that I have set, at the moment I have set it to append. That's why my script appended the result. And now what I'm going to do is I'm going to set this to delete. And make sure you uncomment the property. If it is uncommented only, it will be enabled. So I have uncommented already, and I'm going to save the property file. I'm going to close the file, and then I'm going to relaunch the Apache JMeter application. And I'm going to open the same file, same JMeter script that I have prepared. And this time I'm going to save my data to a different folder. And I'm going to execute my script. Right, now the execution has stopped, and I'm going to go to this results folder. It was appended results. This time I'm saving the data to results folder. So I'm going to open the results folder. And here you can see I have a CSV file, which has been generated by the script that I have executed. And the file size is 4 KB. And I'm going to open it now. Yeah, so you can see I have data up to line 19. And what I'm going to do is I'm going to close this and execute the same script again. So I'll keep this like this so you can see how the file size changes once I execute the script. So it's 4. And I'm going to execute the script. You can see file size change 0, again 4. That means it is deleting the previous data and it is storing the new responses data of the current execution. So if I open the CSV file, you can see that I have data up to only line 19. Yeah, so this is how you execute a simple JMeter script in your local machine, but this is not recommended because maybe your machine may be running other applications that can affect the real latency of the test that you run. So you can always opt to remote execution or distributed execution. So let me go back to the slide. Yeah, so this distributed or remote execution means using multiple systems with client master slave configuration to test the performance of an application or a server. And here we use a slave system to handle the test execution on the remote clients who are acting as slaves to execute the test on the target server by following the exact conditions set by the master system. And by doing so, we can achieve higher number of concurrent users requesting the same target server. And in order to have a smooth flow or a smooth test run, there are few prerequisites that we should follow, like having multiple computers, both master and slave system with JMeter installed in each, and firewalls on all the systems are turned off or other required ports are enabled for connection. And all the systems are on the same subnet. Here you can see in my diagram here that I have presented here, in the slave machines and in the master machine, I have the same subnets. And another thing that you have to consider is installing JMeter on each system can access the target server, and installing same versions of Java and JMeter on all the systems. And then we have to configure our slave system. In order to do that, you have to execute the JMeter server.patch file, which I have already done. And then you have to configure the master system. So let me show you how to do it. So in order to do that, you have to again open the JMeter property file in your bin folder. And there's a property called remote_host. So you have to find it. Yeah. And to that property, you have to give all the slave system that you have configured separated by command. So I have 2 slave machines that I have configured with 10005 and 10006. And I have mentioned them by separating using separating. I have separated by those by command, by a command. Right. Then what you have to do is you have to open the JMeter script in the GUI mode. And once you go to this run tab, and if you hover over this remote start, here you can see all the slave machines that you have configured. So I have configured 2 slave machines. So I can see both of them here. And there are a few other options also available, which you can use to handle the remote execution, just like remote start all, remote stop all, remote shutdown, and etc. And yeah, so we are all ready to start our remote execution. So what I'm going to do is I'm going to click on this run, and I'm going to start both slave machines at once. So once the test is executed, we can see the execution data related to remote execution in our master machine, and the other data related to, the log data, we can see those log data in the slave machine. Yeah, so I think with that, we can conclude the first half of the session. And if you have any questions, I'm just reminding you, you can just post them in the chat. And over to you, Jude.
Good evening, everyone. So Thilani explained in a good way, saying that how we can execute our test cases and how the tests get executed in an order and so on. So in my session, I'm mostly going to cover about while we are running our tests, how we're going to collect our measurements and what are the available matrices and the purpose of we use performance matrices and so on. So let's go into the session now. When it comes to JMeter provide a element called listener to capture our measurements while we are running our performance testing. Okay, so the listeners help us to monitor the request which is sent from JMeter, as well as to analyze the system which is under test. So there are a variety of listeners available in JMeter, and that can be selected based on how you want to view your results. So when it comes to listeners, there are 4 types of listeners. So one is log, then next one is tree, graph, and table. So in the session, I will cover from each of these and explain what sort of information getting collected and how we use the listeners and how we can place them. So now we are in the JMeter, and I'm going to use this test plan for my demo. And you can see there are 2 thread groups in my test plan. So thread group 1, and then the thread group 1 has a simple controller. So I use this simple controller to group my samplers. So in this simple controller is for weather request, and there are 2 samplers here. And then when you take thread group 2, there's one simple controller, say book of flight, and then you have 3 samplers here. So what I'm going to do is I'm going to add listeners, couple of listeners here. So first I will add a listener to the test plan. So you can go add and then listeners and view results tree. And I will rename this as listener 1. And then I'm going to add a listener to the thread group 1. And I'm going to name it as listener 2. And then I'm going to add a listener to a particular sampler. And I'm going to name it as listener 3. And also even you can add a listener to your simple controller as well. And I'm going to add as 4. Now what I'm going to do is I'm going to execute my test. So when you see the results here, don't worry about the failing part, so I will explain later. So here I have added the listener to the simple controller. So it is collecting the results for the samplers which are inside the simple controller. And if you take the thread group also, thread group will collect all the samplers results which is under this thread group. So if you take the view results tree 3, so it's collecting only for the particular sample results. And if you take the view results tree 1, it's collecting all 5 sampler results. So that means when you place your listeners, you need to make sure that you are placing them in the correct place. In case if you place it under the sampler in one sampler, and if you run the test, you might miss other request samplers details. So that's about placing your JMeter listeners. Now we will look into a couple of listeners and I explain what sort of information getting collected and so on. Like I mentioned before, so this test is failing, right? So you have seen in previous session as also most of the people are using the view results tree when they are running or when they are scripting the JMeter. So this is because this listener help us to like debug or troubleshoot the issues that we face. So here you can see the issue is my sampler request is failing, and you can see first you can see what's the response code. So there's saying that syntax exception, but in the response message it's saying that illegal character in a query, right? So and say you want for more details, then you can go to request and see whether you're in the request body you're sending the details are correct. So here if you see you are passing a variable, and that variable value is not getting captured here. So that means you have made some mistake with the variable. So if you go to your user defined variable, and you can see the API key is start with a simple, but the actual results is going with capital. So likewise, it's easy to troubleshoot. Even if you go to the response data as well, you can see what's the issue, and you can it help you to troubleshoot the issue. So I'm going to fix this one. So I'm going to my request and see I have made a mistake. And if you change it, and again, if you run it, so now even it's failing again. So now you can see there is another drop down here. So here the response is failing. So the expected to contain is 201. But if you go here, you can see it's 200 and the response message is okay. So again, I have put the wrong response assertion. So you can go here, you can change it, because normally 201 is the response code is for something got created successfully, that you will get 201. But if the normal response will be 200, okay. So if I go here and if I run it again, you can see the tests are passing now. So it's this view results tree is mainly used for like troubleshooting purpose and so on. And you need to remember that when you are running your performance testing, you should not use this because it consumes a lot of memory. So you should disable this and run your test. And also say in case if you're on your view results to enable it, and if you're running it, then you can use this scroll automatically, because if you're running for a lot of users, it automatically scroll the results. And also when you go to request, you can see the HTTP way as well, say what is the method and so on. And then you can see it as a row as well. And again, when it comes to request, you have request body, request headers, and also when it comes to response data, you can see the correct data are coming or not, and then you have the response headers as well. Even you can search inside your what do you call the responses as well, with the case sensitive or with regular expressions as well. And like Dilani mentioned that you can save this log format as well. And again, you can collect only the errors, or you can collect only the success. You can choose that. And also while you're saving it, you can configure your table, say the what sort of information you need to include. So if you don't want something here, you can untick it and run it. So this is more about view results tree. So what I'll do is I'll show you another results. And I'm going to use view results in table. So this is a table format. So I will run the test again. So you can see the data is getting populated in a table format. And then you can see here you see the sample number, right? So when it takes this thread, you have like you have configured for one user, but you have two samplers here. So in your results tree, you can see two samples data are here. And then you have the start time for each sampler. And then you have the thread group name. And then this is first iteration of first user, and again first iteration of first user, because since you have two samplers, in case if you add it for two users, so you can see let's get a duplicate one. So this is for second user. So likewise for each sampler results will be recorded here, and then you can see the label for what's the sample's name, so you can match with your sampler. And then you have the sample time in millisecond. That means the response time in millisecond for each sampler request. And then you have status here. So if your request passed, then it's come as green. But if in case if it is fails, if it is assertion fail also, it will get marked as fail and show it as red. Even if your response code anything is fails also, it will the status will be shown here. And this is receive bytes and send bytes. And then you have latency and connect time. So I'll give a brief introduction to what is latency, connect time, and response time. So I'll just quickly move into the slide again. So say if you have a client and then you have a server, and through this communication channel, the requests are sent to server from client. And say the client from the client, a user initiated a request at 0 second, and say it took like 2 seconds to reach the server, and then again another 4 seconds that the server took to process it, and then it took another 1 second to send the request or response back to the client. So in here, what is latency? So the latency will be the time spent on the network. So that means 2 plus 1 will be the latency. It's the process time will not be included under latency. So what is response time? Response time is latency plus the processing time. So here it will be 7 seconds. So when it comes to connect time, so connect time is like how much time it took to connect to the server. So this may be important in most of the cases, because there will be some activity happening while we connect to the server, like SSL handshake. So we need to make sure whether those connection time is as expected. And because if connection time is take time, then it will affect on the response time as well. So we need to monitor the connect time as well. And when it comes to latency, if application under test, and if your loads are load generators and your application the same network, then you will not face any latency, right? But say in the real world, the applications are deployed in production, and if the customers are trying to access the application over the internet from different geographical location, then each user will face different latency values. So we need to make sure when we run our performance test, the latencies are acceptable and it's not causing any performance issues. Likewise, response time also is important, because so when you are accessing a application, and if you face a lot of response issues for like multiple times, then you will be fed up and you will stop using the application. So response time is also really important. So when it comes to bandwidth is like, say this is a water tank. So and is there another water tank? So the water is flowing through this pipe, right? The maximum amount of water travel through this pipe will be the bandwidth. So in performance terms, if we say the maximum amount of data that can be transferred per unit of time through a communication channel will be the bandwidth. Okay, and then throughput will be the amount of the maximum the amount of data transferred from client to server in a given time period will be throughput, or the how much of request that particular server can handle in a given time will be the throughput. So so these the response time, then the what do you call response time, latency, connect time, and all correlated with throughput. In case say if your latency is high, then throughput will be less, because the server able to serve lesser number of requests. So if the response is like if the response time is higher, then again the throughput going to be lesser, because the amount of the request that the server can handle will again get affected. Okay, so this is just I want to cover here, and I'll move back to the JMeter. So you can see that it's capturing latency, connect time, and again the response time in your view results table as well. And here again you can scroll automatically, since it's going to capture for each request, and then you can select only for child samples, and here you can see the total number of samples that are executed and the latest samples, latest samples, the response time, and this is will be the average response time of your entire test run, and then the deviation among this samplers response time. These are the information normally get collected in view results tree. Again, you can save these into a file as well, into CSV or JTL file. Again, you should not use this as well, because while you're running your performance testing, this data, because it's going to capture for each request, then it will consume a lot of memory. Then I'll move into another listener. So we'll see a aggregate report. So again, this is a table format, and then I'm going to run this test. So you can see here now, I have executed 2 samples with 2 users, right? Altogether 4 samples, but for each sampler, it has only one line, because it's accumulating the results. So you have the 2 samples, and it will provide you average response time for each sampler, and also total average time for all the samplers as well. And then you have the median, so that means the middle value. So like half of the user took lesser than this time, and half of the user took more than this time. So this is the median value, and this will be the 90th percent line. So where the 90% of user took less than this time, and the 10% of user took this much of time or more than this. So this is like we ignore the highest 10%. And here you have the 90th percent line and 99% line, and you have the minimum response time value and the maximum response time. Most of the time you can see the maximum and the 99% line will be equal. And when it comes to performance metrics, I will explain further, but when it comes to response time, most of the time we use average, 90th percentile, and minimum, maximum, and all. And here you have the error percentage. So if your test is failing, how much of samples getting fail and all, you can capture that as well. And then throughput, like I mentioned before, how many requests that a particular server can handle in a given time will be the throughput. The more the throughput, higher the performance will be. And then you have the received what do you call kilobyte per second, and the sent kilobyte per second. So these are things captured in aggregate report. And also you can, while you're running it, if you want to include your thread group names, then you can include that by clicking this. And also you can save the table data as with the headers or without the headers. Again, you can save it the file as well. And then I'm going to add another graph listener. So it's going to be aggregated graph. And if you see here, see the same table is populated here, but you can view the results in a graphical format as well. So I will run my test. So data are populated, and if you go to display graph, it will display the what you call the values in a graph format, and you can see the average response time, and the sampler names are here, and this will be the time taken in a millisecond. And you can set, like, say you want minimum and maximum, you can select, and you can see that as well. And then you have the other graph title, and you can set the font size and all. You can do that as well. Again, you can save these results in a graph format, or you can save it as a table as well. So this is another type of listener. And then what I'm going to do is I'm going to disable this thread. For this execution, I'm going to use this thread, and I'm going to run this test for 50 users, and the loop count is forever. And I'm going to schedule this for 60 seconds, because say I'm going to use a couple of listeners here. And so in order to populate some pattern, we need at least have some more user execution. So I'm going to add a couple of listeners here. Listener, so one will be the response time graph, and then transaction per second, and then you have hit per second, and then I will add active thread over time. So I'll just add 4 of them, and then I don't need this, I will disable it. So you can click Control T to disable it, or you can right click and disable as well. Then I'm going to run this test. Okay, you can see test is started. And if you go to add active thread over time, so you can see our threads are getting up. So 50 threads. So you can see that in the graph. And again, you can set your graph settings as well. And if you go to hits per second, you can see the hits that's happening to the server, the number of hits, and the timeline of the testing. And again, if you have multiple sampler requests, then it will capture those ones. And then if you go to transaction per second, so here you can see purchase flight, reserve flight for each samplers, and then how the transaction per second is happening. And then even you can say, I want to view this one. So you can deselect this and run it. So likewise, you can see in a graphical format. And then if you go to response time, and if you click on display graph, see the response time graph is populated. And then you can see your test is done. And if you go to settings, again, you have the interval. So currently it's set to 10,000 milliseconds. So I can set the time interval to 5,000, and then, sorry, you have to apply interval. And then if you go to display, then your time interval will be changed here. And also here, you don't have an option to check box to select your samplers that need to be visible in the graph. So what you can do is you just dot and you add star, and then you give your sampler request name, and then you star and dot, and you apply filter. And if you go here, it will show only the response time graph for the reserve flight ticket. So these are the out of the box graphs that provided in JMeter, and you can collect these results here. So like I mentioned before, you can see most of the time I'm mentioning that you should not run these, you use these listeners while you run your test. So what you can do is, in case if you're running it in your command line, or if you're running it in the GUI mode, but what you can do is you can use the listener called simple data writer. So what it's going to do is going to write the data in a file. Okay, so say I'm going to give the file location here. So, in the previous session, Tilani mentioned about append file, and then you can write the results in the same file also. But here what I'm going to do is I'm going to add a timestamp to my file name. So then it can save multiple files here, because say if you're running test a couple of times and you want to compare your results with different dates and so on, then maybe you can save the files in different tape times. So here you can add this, and then you can select for errors and success, but I'm going to save all the results here. I'm going to cancel it and I'm going to run it. So you can see test is started. And if you go to my file, you can see the file in today's date is created. So that test is running as well. What I'm going to do is I'm going to stop the test, because again, we have to wait. So I have already saved file here. So for example, say I'm going here, go to your chart, and you go to browse. Sorry, I need to first clear the results. And you can go here, even you can open this, I guess. See, the results are getting populated. So after you run your test, you load your results and you can view the measurements and so on. And also even you can use this in the view results in tree as well. Say for example, this one, I go browse and then select it. See, all the request details are here. So you can check whether if anything failing, if why, and you can see why it's failing and so on. So this is what I want to just give a brief idea about the JMeter listeners. Now I'll move back to the slides again. So next topic will be the performance metrics. When it comes to performance testing, running testing and collecting the measurement is not enough. In order to measure the performance of an application, we require a set of metrics. So performance metrics help us to identify the areas of the application which are like weak and creating bottlenecks in the application. So there are two types of data that are involved here. One will be the measurement and the other one will be the metrics. Measurements are the data collected while we running the performance test. For example, the response time for a particular sample. And metrics are calculation made with the specific formula which is applied to the collected measurement, like average response time, median, or like 90th percentile, like those are the metrics. So in summary, it is really to track the performance metrics, to define what areas and the features require like increase attention when it comes to our application performance enhancement. So when we take performance metrics, there are a lot of metrics you can collect during your performance execution. So taking too many metrics also, it's not good, because it will difficult to do analysis, as well as it will negatively impact the application performance. So therefore, we should identify the metrics according to the application, or according to our goal of performance. So for today session, I will cover a couple of commonly used performance metrics. So first one will be the virtual users. So virtual user status. So during the performance testing, we try to emulate the real users behavior with help of virtual users. So in JMeter, we use the thread to emulate virtual users. So during our performance testing, it's really important to monitor the status of our virtual users. So how many users got passed and how many users got failed. So during our performance test, in case if the number of failed user status are high, then it's no point of continuing our test and evaluating our collected metric, because with the if the test, most of the tests are failing, it's no point of continuing the test. So first we need to identify why these users are getting failed, and we need to fix the issue first. So next will be the transaction per second. So if the majority of the virtual users are got passed, and if you think the collected data are eligible for our analysis, next we are going to check for response time. So like I described before, response time means the total time taken to response to a particular request or a service. So when we analyze the JMeter results, we don't get the response time for single thread. So the response time shown in the JMeter results is for multiple threads. So it will be really difficult to say how much time is taken for a single thread in case if we need to use metrics like, so in this case, we need to use metrics like response time, average response time, minimum, maximum, and 90th percentile. So that those are the commonly used metrics when it comes to transaction response time. So the faster the response time, the higher will be the performance. Next will be the transaction per second. So another important metrics when it comes to performance testing is transaction per second. So for example, if you take a workflow where you have to log into application and you search for an item and you need to place order. So where login is one transaction, search is another transaction, and placing an order will be another transaction. So we have 3 transactions available in our workflow. So from those transactions, how many order transactions were able to handle by our server? How many the search transaction that our application able to handle? Likewise, we need to monitor that. So the transaction per second metrics help us to calculate the total number of successful and unsuccessful requests per second. So the higher the number of successful transactions, better will be the performance of our application. Next will be the hits per second. So hits per second metrics help us to calculate the number of hits that the server can handle in a second or in a given time. Also help us to understand the server scalability, or how much stress that our server can handle. Next will be throughput. So throughput, like I mentioned before, that is also important performance indicator when it comes to performance testing. So say, like I mentioned before, like say if you have a water tank and the water is traveling from point A to point B, and the amount of water flowing from the pipe in a given time can be the throughput, right? So in performance testing term, if we say the amount of data moved successfully from one place to another is in a given time period will be the data throughput. So it is typically typically measured in bits per second. So the more the throughput, higher the performance will be. The next will be the HTTP response per second. So it's mainly captured with the HTTP response codes. So how many successful response, like 200, if any internal server, how many internal server responses, like with those minimum, maximum, average, we calculate it. The next one will be the CPU metrics. So the CPU usage indicates the amount of CPU utilization. The higher CPI utilization is sure that it will bring the lot of application performance issues. So when running the performance testing, we need to monitor the CPU utilization pattern in the application server as well as in our database server. Normally, when the CPU utilization is more than 60%, we will get a warning. And when the CPU utilization is more than 80%, then we get a red alert. So CPU usage is a critical aspect of when it comes to enhancing performance. The last one will be the memory usage. The memory usage metrics determines the amount of memory required to process a request. The metrics also give information about the amount of memory used during the execution and the free space available. So these are the commonly used performance metrics. And then we look into some of the common performance issues. So in this session, I'm going to cover only 3 of them. So first one will be the degraded response time. So when we're running our performance test, we can observe that the server response is looking good in the start. But over the time, response started to degrade slowly or intensely. So these kind of issues mostly caused by like when you have memory leaks, disk fragmentation, or like the extra growth of the file repository, or unacceptable database growth. So these can be the issue for the degraded response over time. The second will be inadequate or graceless error handling under heavy or over limit load. So what that means is like in some cases, the response time may be acceptable when we have the normal load. But when we increase the load over the time, the server started to respond with errors. So these kind of issue can be caused by like insufficient resource pool or undersized queues and stacks. And when we set to quick timeout settings, likewise. And the third one will be the slow response time under all load. So in some cases, the response time is unacceptable in even there are no loads. So normally when we do our normal testing, like when we test our application, sometimes you can see the application is not responding back. So these things can be captured during our normal testing, or when we run like single user performance testing. So so when it comes to performance testing, we need to make sure that we ran at least one set of single user tests to make sure that the application under our performance criteria, and then you go for a larger scale of performance testing. So these kind of issues can be occur because of bad database design, or can be a bad implementation, or even because of the network latency. So So these are things that I want to cover in my session. So mostly about how the listeners can edit and what type of listeners are available in JMeter and the common matrices that we use in our performance testing and the common performance issues. So in the next session, tomorrow's session, Sugandhika will be talking detail how to, with these results, how to identify your performance problems or bottlenecks, and also what are the common performance issues and how to overcome with those. So tomorrow session that will be there, so please don't miss it. That's all for today. So thank you for joining, guys, and hope to see you again tomorrow. Thanks everyone.